We're tackling contains duplicate 2, which we want to try and solve with minimum complexities as shown here. On in time and on in space. The problem statement wants us to determine if there are any two distinct indices, I and j, in the given array nums, such that nums I is equal to nums j, and the absolute difference between I and j is at most k. So it's quite difficult without visualizing it, but we need to check if there are any two distinct indices with the same value such that their absolute difference is at most k. Your options for the optimal solution to this are A. Sorting, B. Cumulative sum plus hash table, C. Sliding window plus nested loops, or D. Sliding window plus hash table. I'm going to pause for a couple of seconds while you make your choice. So, for those of you who are able to get it, congratulations. And for those of you who just want to see some code, the answer here is D. Sliding window plus hash table. Taking a look at the brute force approach, we would simply check every pair of indices in the array, comparing the values at those indices. We would iterate through all possible pairs, checking if their values are equal, and if the absolute difference between their indices is at most k. Obviously, using nested loops would increase the time complexity to at least on squared. And we can do a lot better than that with our optimized solution. In this, we're using the sliding window plus hash table technique to solve the problem more efficiently. Our idea is to iterate through the array and store the indices of previously encountered values in a hash map. So you can see we've got our hash map, and then we're simply storing the index of these values. While iterating, we check if the current value already exists in the hash map, and if the absolute difference between the current index and the stored index is at most k. That's this line. If both conditions are satisfied, we return true, indicating the presence of a duplicate within the given range. However, if we reach the end of the array without finding any duplicates, we're going to return false. Let's look at the line by line. First of all, we're declaring this unordered map called myMap, the hash table, which will store the previously encountered values as keys and their indices as values. The time complexity here is O1, but space would be ON. We're also using n, which is simply the size of the array we were given, and then we've got a for loop, which iterates through each element in the array. The key line here is at line number 7. This line checks if the current value, nums I, already exists in the myMap, and if the absolute difference between the current index I and the stored index at myMap nums I is at most k. If that's the case, then we're going to return true. So, if both of these conditions are true, it means we found a duplicate within the given range, and we must return true here. However, if we don't find that duplicate within the range, this line, myMaps nums I equals I, will update our hash table by storing the current index I for the value nums I. If that value already exists in the hash map, but wasn't within the range k, then it's going to get updated with the latest index. Finally, if no duplicates are found within our given range, our function's just going to return false. So, that's another problem solving session completed with Coding Card Shop. Let's look one more time at the problem statement itself. To solve this relatively easy problem, contains duplicate 2, you have 4 options. And as we've already demonstrated, the answer is sliding window plus hash table. The reason why is probably not as complicated as the length of this answer. I think this is one of the easier problems to solve. And if you need extra help, we have provided some solutions in different languages. Python and Java are a bit more popular than C++, unless you're involved in competitive programming. Finally, I think that the Udemy course that we've taken this problem and solution from will be very helpful if you're still struggling with the answers that we've provided. Dr. Ibrahim, as I always say, provides a more technical and more visual explanation than the one that our app provides. In any case, I hope that that's helped you with this problem, and I wish you the best of luck in your future interviews.